Hello, it's Dr. Ruddy. Welcome back to Morning Rounds. I want to talk to you today about the use of CRISPR and cancer therapy. So let's begin with a discussion and a definition of what is CRISPR. You may have heard of it, you may have even come across some definitions, but in my experience, not everyone actually understands what CRISPR is. So let me see if I can't give this a shot at explaining it to you. So CRISPR, C-R-I-S-P-R, all caps, is a kind of editing tool. So let's start with a very easy to understand metaphor. Let's say you are standing in front of a tapestry, say a unicorn tapestry at the Metropolitan Museum of Art. And you come in close and you see there are a million stitches, very, very tiny. There are, for the sake of this argument, approximately as many little stitches as there are proteins in the human genome. So there are a lot of stitches, and you're looking very closely at these stitches. This is all very beautiful, intricate work, and you notice that there is a blue stitch where you think there should be a green stitch. And you are now the curator of the museum, and you have the power to go in there with a tiny pair of scissors, and you clip out what you think is the erroneous stitch, and you sew it up, right? Because if you take out a stitch, as you know, the whole thing can come unraveled. So you snip out the stitch, and you sew it up so that it's now perfect, and you're very pleased. Well, that, in a nutshell, is CRISPR. So let me now explain to you more specifically what that CRISPR technology is with regard to biologic systems, cells, living cells. So CRISPR turns out to have been discovered as an immune surveillance system. It was found in bacteria, and CRISPR is a system that is used for immune surveillance. Well, what is that? That means that CRISPR goes around looking for foreign bits and pieces that do not belong inside the bacteria. So CRISPR is a kind of immune surveillance monitoring device that goes around looking for strange bits of DNA. Well, how might strange bits of DNA get inside a bacteria? Well, that's easy, because viruses invade bacteria. Viruses that invade bacteria are called bacteriophages. So the virus injects its DNA inside the bacteria, and this viral DNA worms its way around, and it inserts itself into the genome. Basically, it takes a seat at the table like an uninvited guest, and it sits there like it belongs there. But along comes CRISPR, and CRISPR is the immune surveillance system, and it's there to find DNA that doesn't belong there, and so it goes around checking IDs, and this guy belongs there, and this person belongs there, and all of a sudden there's something that doesn't belong there. That's the viral DNA, and CRISPR snips it, gets rid of it, and sews the genome back together with the help of its partner, Cas9. Great. The advantage is that not only does CRISPR get rid of the unwanted virus, but it keeps a record of that virus. So any other virus like that tries to get inside the cell is immediately attacked. Furthermore, CRISPR then keeps an ongoing catalog of all of these invading viruses so that any similar virus that comes into the cell is going to get the axe, but all of the progeny, all of the daughter cells of that bacteria will also be given this information and the ability to get rid of similar viruses. So this is an extremely powerful kind of defense mechanism that bacteria have developed over millions of years. It was recently discovered by scientists and put to good use, we think, although we have to be careful. The Chinese have taken DNA out of human embryo. Scientists in California have removed HIV from an infected cell. People all over the planet now are using CRISPR technology, which is very easy to use and master, as it turns out. It's a relatively small processing device. They're using it to edit the genome of all types of living cells. How might this be useful for cancer? Well, as you know, cancer is precipitated by mutations, and some of those mutations, at least 20% of them we think, are related to tumor viruses. So, for instance, if scientists can remove HIV from an infected cell, then we have the potential to remove viruses such as the breast cancer virus, the human papilloma virus, all kinds of tumor viruses potentially. We have the ability to do that, we think, although we need a lot more experiments to be able to prove that. And we also have to be very careful from an ethical point of view that we don't just go running off in an infinite number of directions, snipping at the tapestries, because you can really change what the image looks like. And I don't know that we have enough information yet to change the images quite yet. But certainly the ability of CRISPR to identify and ferret out unwanted DNA, specifically that related to unwanted viruses, is extremely powerful and may allow us to make a real giant leap in the advance of understanding the viral cause of human cancers, as well as either treating them and certainly through vaccines preventing them. So, as I have said previously, it's worth repeating, the breast cancer virus causes breast cancer in mice. We found it in 40 to 94% of human breast cancer. But I want to point out that this breast cancer virus is actually an all-purpose tumor virus. It's been found in many other kinds of human cancers. And so, whereas it may cause cancer when it infects the cells of the breast, it may very well cause cancer when it infects other cells in the body, lung, endometrium, and other kinds of tissues. So I hope that helps explain a little bit more about CRISPR technology and its potential, I think, in understanding the viral cause of cancer and perhaps new and better ways to both treat and prevent it. Thank you so much. If you have any questions, feel free to leave them in the comments below. Thumbs up to you, thumbs down to breast cancer.